Welcome at congatec. Welcome at the introduction of the highest performance computer module standard, COM-HPC. My name is Christian Eder. I'm the Director Marketing at congatec, but I'm also Chairman of the PICMG workgroup for COM-HPC. Today I'd like to give you a quick introduction about COM-HPC, the new module standard. Why was it required to create it? What are the details, what are the use cases, and what products can be expected? Before we dive into the details of COM-HPC, let me emphasize that COM-HPC is not a replacement for COM-Express. COM-HPC goes completely on top of COM-Express with the functionalities, with the feature set, and especially with the performance levels. And don't forget, congatec is creator of open standards. Why was it necessary to create something new? The COM-Express connector got its limitations. So the maximum of 32 PCI Express lanes on the Type 7 modules is limited to the speed of 8 gigabits per second, as this is defined by PCI Express Gen 3. There are also fast gigabit Ethernet lines, but it's limited also to 10 gigabits per second. The target for next generation of computer modules was to support minimum of PCI Express Gen 5, minimum of 64 PCI Express lines, and support for 25 gigabit Ethernet, and of course to update all other interfaces with USB 4, just as to name one. The subcommittee at the PICMG COM-HPC consists of 26 active member companies. The whole activity was started by IDLink, Contron, and congatec, and I have the honor to serve as chairman, but we also have official positions served by Contron and Samtec. Let's talk about the most important component, the connector, which really differentiates these single computer module standards. The connectors which have been chosen are flexible in the stack height configurations. There are combinations with 10mm stack height, which allows for certain components underneath the module. The 5mm version is very slim, but it's not possible to place any components or just extremely slim components underneath the module. The module connector itself, the connector you see on front, is always the same. The connector got 4 rows. 2 connectors are used here for COM-HPC, 2 connectors with each 400 pins. So it gets a really high density, it gets a performance. This connector is already specified to 56 gigabits per second. Remember, PCI Express Gen 5 has 32. And it's available on multiple sources. It's not a single source component, which is important for an open source standard. The connector is soldered by BGA balls, which means there's a micro justification, which is important for extremely high accurate positioning of the connector. That the fitting between module and carrier is quite easy. And it got an enhanced contact system with quite long contacts, which means even with some movements, some shock vibrations, a reliable contact is guaranteed. During development of the spec, we put a lot of emphasis on optimizing everything we could. Even the trace routing from the connector to the boards on the module and on the carrier have been tested and simulated. You see also the ground schemes here. The dots you see in the graphics, ground, signal, signal, ground. That's one differential pair. And it was completely simulated and tested how to break out the signals. So the high-speed signals, it's quite important to avoid any extra trace lengths or any extra vias. And as a result of the study, the connector was modified. The row-to-row spacing was enhanced, which provides better crosstalk and easier breakout of the signals. COM-HPC follows the successful computer module concept. It separates the PC functionality to the module from the customized I/O functionalities from the carrier board, which means one module can serve multiple applications, and the differentiation to the application does happen completely on the carrier board. All special I/O is implemented on a customized, or let's say application specific carrier board, while the module itself is always the same. On top, COM-HPC defines a heat spreader definition, which acts as a thermal interface to this system cooling. COM-HPC defines two different types, a client and a server type. The COM-HPC client type is typically utilized by the smaller sizes A2C. It provides up to 48 PCI Express lanes. There's even one extra PCI Express lane which is dedicated for a board management controller for out-of-band management on the carrier board. It has a rich I/O interfaces here for audio and video, up to 4 video channels. New serialized audio is implemented. All interfaces are brought up on this 800 pins, so a lot of headroom here for extensions even for the future. And it does support up to 2 times 25 gigabit Ethernet plus 2 base T Ethernets. So a lot of connectivity, but of course it also supports a USB 4 as highest performance USB implementation nowadays. Driver behind this standard is the enhanced speed of PCI Express, for example. So the I/O bandwidth of PCI Express doubles every 3 years. That's a theory, but in practical life it's even faster. Doubling happens much more often. So we talk about PCI Express Gen 5 already, and PCI Express Gen 6 is expected to be available somehow in the time frame of 2022. The specification is still in progress, but this will double again the performance of PCI Express. Also, USB had a strong development looking to the past here with the performance of USB 2.0, which is almost not recognizable here on the graphics, but it scales really up here to up to 40 gigabits per second with Thunderbolt 4 implementations. All of this needs to be supported with an up-to-date computer module standard, and it is supported by COM-HPC. The evolution of the screen resolutions is also a technology driver. Looking to DisplayPort 2.0, performance levels up to 80 gigabytes per second for a 4-line implementation are state of the art nowadays. Screens are available and processors do support 8K screens nowadays. The COM-HPC server is, as the name says, much more server oriented. It does not support any video interfaces or audio interfaces, but it supports a much higher amount of PCI Express and mainly Ethernet interfaces. It's up to 8 times 25 gig Ethernet connectivity. The server modules are typically on larger size modules, which means up to 1 terabyte of DRAM based on today's available technologies can be implemented. So all in all, with 64 PCI Express lines, with one dedicated PCI Express line on top for the board management, control of out-of-band management on the carrier board, this is a perfect feature set for edge type of servers. Driver behind this performance requirements is Ethernet. The 100 gigabit Ethernet implementation is state of the art nowadays. It's standard in type of data center applications, but it will also be implemented more and more in the industrial environments. Quick overview about client and server types shows that the server has much more Ethernet and some more PCI Express lines, while the COM-HPC client has SoundWire and 4 display interfaces. A lot of interfaces, smaller interfaces, are in common, and both standards support also USB 4. But the client has even up to 4 times USB 4 possibilities. Let's talk about size definitions. COM-HPC defines in total 5 different sizes. So the smallest implementation, the size A, with 95 by 120 millimeters, is about the size of a COM-Express basic module, which means the smallest COM-HPC size is about the largest COM-Express size. It's also a clear sign that COM-HPC extends the possibilities of COM-Express, and it scales up to the maximum size of 160 by 200 millimeter for the size E, which is typically used for a server. And the requirements, the real estate requirements for the server are so high as a lot of DRAMs and full-size memory sockets should be supported. With the highest speeds on the IOs, there are new challenges upcoming here for signal integrity. It's the interfaces which gets faster and faster, which requires special attendance. To name some, it's PCI Express, it's USB 4 with Thunderbolt, it's the display port or the other video interfaces, and it's Ethernet. The low voltage differential signaling is a big challenge in the meanwhile for the highest frequency ranges, and the challenge will go on with PCI Express Gen 6. It's planned to have a PAM, pulse amplitude modulation, with 4 levels. So you see, signal integrity is an issue and will become an even more important issue for the future. The COM-HPC specification already includes clear guidelines how to work with these fast signals. So these guidelines include a PCB stack-up, routing rules, and also calculation of the maximum trace lengths for different interfaces. On screen you see an example here for some PCI Express device down implementations. You see the maximum trace lengths depends also on the used PCB materials. All of this information is already included in the specification to make the implementation as easy as possible. There's also a platform management specification in preparation, which in fact is more or less an IPMI implementation, but a reduced feature set of IPMI to make it easy to be implemented here to operate edge servers. But it also includes some extra features, some new functionalities which are important for embedded use cases. This specification is still cooking and should be released mid of 2021. Congatec already introduced its first COM-HPC client module. This is a size A module, which means it's the smallest of the COM-HPC sizes with 95 by 120 millimeters. It's featuring the 11th generation Intel Core UP3 processors. Those are the single chip processors with a lot of with low power envelope, 10 nanometer structure with great integrated graphics. It can feature all 4 video channels from COM-HPC. And it's the first processor in this range to support PCI Express Gen 4 lanes. So the performance of COM-HPC can be used, and even with USB 4, the new feature set can be used. On top, this module is fully industrial specified, which means operating temperature from -40 up to +85 centigrade. And it does feature a lot of real-time possibilities. Of course, real-time computing is an integrated part of the concept, but it also has TSN-capable Ethernet implementations up to 2.5 gigabits for real-time and time-coordinated computing and communication. But the module itself is not the full story. A good module vendor has to provide a complete ecosystem. And we have the cooling solutions, as you see here on the picture, and we have also the carrier boards available. The Congatec ecosystem, of course, includes coolings and includes the carrier boards. Important for the evaluation carrier boards is that Congatec provides the schematics and the technical details to its customers for free. So this can be used to start from scratch at a quite high level with a carrier board which can hold the complete special features which are required by the customer, by the application. And we also support personally the projects, and we are offering trainings. So make sure to check our webpage for the latest schedules for the COM-HPC in-depth trainings. What are the target applications, the typical target applications for COM-HPC? Of course, everything which is real-time related, robotics, motion control, that's an important large market for COM-HPC. High-speed test and measurement machines, just like testing 5G networks and so on, is also a key market to be addressed by COM-HPC modules. COM-HPC is also important for the smart infrastructures. So more and more data need to be processed, more and more AI does happen, and this data must be processed somewhere at the edge. So a lot of servers will move from the data center somewhere to the edge outside to do the processing, or at least the pre-processing, and this is the predominant market for COM-HPC modules. Thank you for your attention. Find more details at congatec.com/com-HPC and make sure to talk to our specialists about your COM-HPC applications.